All right, the exterior angle theorem. This is a good one. Let's take a look at this shape here real quick. This is called a triangle. Some simple things that we already know about this great triangle is that, one, it's got three angles. All right. What we've studied in the past, the triangle sum theorem told us that every single time angle 1 plus angle 2 plus angle 3 has to equal 180 degrees. That's a given every single time. All right. I can create another situation if I extend one of these sides. This creates an angle on the outside. This would be our exterior angle. Well, that exterior angle creates a relationship right there with angle 3. This is called the linear pair theorem. With the linear pair theorem, I know that angle 4 plus angle 3 has to equal 180 degrees also. Well, if we start looking at this situation, if this part of this equation is the same as this part of this equation, then we know 1 plus 2, these angles out here, which are referred to as the remote interior angles, all right? Remote meaning they're separate from this situation over here. They're the interior angles furthest from the interior angle next to the exterior angle, all right? We know that 1 plus 2 better be the same as angle 4. This is what's referred to as the exterior angle theorem, which we mentioned at the very top. All right, angle 1 plus angle 2 has to equal the angle furthest from them on the outside. Okay, which leads to we would want to take a look at an example, of course. All right, so let's look at an example. So if I had a triangle and somewhere there was created an exterior angle, and let's say this interior angle measured x plus 20 degrees, and this exterior or interior, these are the two remote interior angles. Let's say this one was let's go x plus 80 degrees. So the exterior angle theorem says that this angle, 3x plus 50, the exterior angle has to be the same value as the two remote interior angles added up. So x plus 80 plus x plus 20. Well, we've got an equation. Now we can solve. Let's just combine our like terms on the right side. We're at 2x plus 100. Let's move all the x values to one side. And then move our constant values or numeric values to the other side. This will help me track down a value of x that makes this true. Just remember, again, if you want to know what each angle equals, then this value of x has to be plugged in. So 50 plus 20 means this angle is 70 degrees. 50 plus 80 is 130 degrees. Again, we would want to trust our math because obviously my numbers don't look so great. And then I've got 200 degrees over here, which makes this a totally ridiculous problem, but yet a decent example of the application of the exterior angle theorem. And I'll do a better job in the future making sure I have workable numbers. All right? But make sure you see where the relationship comes from. All right? Remember, these two angles added up have to equal this one on the outside the exterior angle. All right? And that is an example of the exterior angle theorem.